Welcome to this video on SQL and cloud databases. We'll be exploring how to work with SQL in Amazon Web Services, Azure and Google Cloud Platform. Let's dive in. In this video, we will provide a Cloud SQL overview. Cloud SQL refers to managed SQL databases that are hosted in the cloud. These services reduce the burden of infrastructure management, allowing you to focus on your data and applications. Cloud SQL solutions provide automatic backups and high availability, ensuring your data is safe and accessible. They also offer scalable performance and storage, allowing you to adjust resources as needed. Cloud SQL databases are offered by various cloud providers. Some of these include AWS Relational Database Service, Azure SQL Database, and Google Cloud SQL. Let's explore Amazon Web Services Relational Database Service, also known as RDS. Amazon RDS supports several database engines including MySQL, PostgreSQL, MariaDB, Oracle, and SQL Server. RDS automates tasks such as backups, patching, and failover, simplifying database administration. Multi-availability zone deployment can be used for high availability, ensuring your database remains accessible even in the event of an outage. Here is an example of how to connect to an RDS MySQL instance. First, connect to the RDS MySQL instance using the command use_my_database. You can then create a table named products with columns for ID, name, price, and create it at timestamp. Finally, you can insert data into the products table with values for each column. Let's move on to Azure SQL Database. Azure SQL Database is a fully managed SQL Server database as a service, providing a robust platform for your data. It offers built-in intelligent performance features that automatically optimize query execution. Advanced security features are also included, ensuring the protection of your data. Geo-replication and automatic failover groups provide business continuity and disaster recovery capabilities. Below is an example of how to query with JSON support in Azure SQL Database. This query selects the ID, name, price, color, and tags from the products table, where the in-stock value in the metadata is true. The results are ordered by price in descending order. Next, we will explore Google Cloud SQL. Google Cloud SQL supports a variety of databases including MySQL, PostgreSQL, and SQL Server. It provides automatic replication and failover capabilities. It seamlessly integrates with other Google Cloud Platform services. Automated backups and point-in-time recovery options help protect your data from loss or corruption. Shown here is an example of working with PostgreSQL in Google Cloud SQL. First, we create a table with GIS capabilities called locations. We insert a point using PostGIS, specifying the name Google Headquarters and its latitude and longitude coordinates. Let's explore security and compliance in Cloud SQL. Cloud SQL services offer several security features. One of the most important is encryption, which protects your data both at rest and while it is being transmitted. Virtual Private Cloud, also known as VPC integrations, allows you to isolate your database instances within a private network. Identity and Access Management, also known as IAM, enables you to control who has access to your databases. Cloud SQL services often comply with industry standards such as SOC, ISO, PCI DSS, and HIPAA. To create a role with limited privileges, the command is create role read-only_user. We grant only select permissions using the command grant select on customer_data to read-only_user. We can audit all login attempts using the command create trigger audit_login after login on database for each statement execute procedure log_login. Here are some tips for optimizing performance in Cloud SQL. Use proper indexing strategies to speed up query execution. Optimize query patterns and join operations to reduce resource consumption. Take advantage of cloud-specific performance tools offered by your cloud provider. Use connection pooling and caching to minimize latency and improve response times. Here's an example of query optimization. The unoptimized query selects all columns from the orders and customers tables, joining them on the customer ID, where the order status is shipped. The optimized query selects only the ID, date, and name from the same tables, applying a limit of 100. Cloud SQL offers a range of advanced features. Auto-scaling allows you to dynamically adjust compute and storage resources based on workload demands, ensuring optimal performance. Serverless options let you pay only for what you use with on-demand SQL database instances. Machine learning integration enables you to run machine learning predictions directly inside your database queries. Multi-region deployment allows you to distribute your database across geographic regions for low-latency access. Here is a machine learning integration example using BigQuery ML. We can create a machine learning model using the command create model my_dataset.product_recommender. We can get recommendations using the ML model with the command select * from ml.recommend. Let's review database migration strategies. Step 1 is assessment. Begin by evaluating your database size, schema complexity, and dependencies to plan the migration process. Step 2 is schema conversion. Adapt your database schema for compatibility with the cloud environment. Step 3 is data migration. Transfer your data using cloud-native tools with minimal downtime to ensure business continuity. Step 4 is testing. Validate data integrity, application compatibility, and performance in the cloud environment. Step 5 is cutover and optimization. Switch to the cloud database and implement cloud-specific optimizations for optimal performance. There are various migration tools that can be used for migration. Some of these include AWS Database Migration Service, Azure Database Migration Service, and Google Cloud's Migration Service. Let's summarize the best practices for Cloud SQL. Implement proper backup strategies to protect your data from loss or corruption. Use connection pooling to optimize database performance and reduce latency. Apply the principle of least privilege access control to enhance security. Monitor database performance metrics to identify and address potential issues. Leverage cloud-specific optimizations to maximize performance and efficiency. Cloud SQL databases provide powerful management features while maintaining SQL compatibility. Each cloud provider offers unique capabilities for different use cases. Migration requires careful planning, but delivers significant operational benefits. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.